Okay, let's try some more challenging problems in computing present value. Before we start though, let's keep in mind that although these problems are more difficult than the basic problems, they all make use of the same following equation, which simply tells us how to discount future cash flows. Present value equals future value divided by 1 plus the interest rate to the power n, where n is the number of years between the present and the future. Okay, our first problem doesn't require any calculations, but you can answer it either intuitively or using a little bit of algebra. So take a look and hit pause and give it a try. The answer is asset A. By the way, this assumes that the interest rate that prevails is positive, and I'll make that assumption for all of the problems going forward. If that's not true, then in most cases the answer will reverse on these types of questions. Intuitively, the bond or the asset that pays us back sooner is worth more because payments further out in the future are worth less than payments closer to the present, all else equal. And since both assets eventually give us $200, the one that gives us our little bit of money earlier is worth more, and that is asset A in this case. We can show this algebraically by comparing the present value of asset A to asset B. A is simply equal to the present value of the two cash flows, 100 divided by 1 plus I for the cash flow that occurs in year 1, and 100 divided by 1 plus I squared for the cash flow that occurs in year 2. We want to see if that's greater than, equal to, or less than 200 divided by 1 plus I squared, which is the present value of the cash flow associated with asset B. Okay, now we're going to do a little rearranging. We're going to divide both sides by 1 plus I to make this a bit clearer. And in doing so, we'll see that we end up with the question, is 100 plus 100 divided by 1 plus I greater than, equal to, or less than? I'm going to write 200 this way, 100 plus 100, you'll see why in a second, divided by 1 plus I. If we subtract 100 divided by 1 plus I from both sides, what we end up with is what I hope is a fairly simple comparison to make. It's the question of whether or not 100 is bigger than or equal to 100 divided by 1 plus I. And since 1 plus I is bigger than 1, the left-hand side is bigger than the right-hand side. In other words, the present value of asset A is larger than the present value of asset B. Okay, so far so good. Hopefully good. Let's try this one. It's pretty much just plug and chug, but give it a shot. The only wrinkle in this problem is that I've included a cash flow that occurs halfway through the first year. But this is really no problem at all. I have two cash flows and I'm simply going to add the present value of each. The present value of the first cash flow is 100 divided by 1 plus 0.08 to the 1/2 power, since this occurs 1/2 year from now. And the present value of the second cash flow is 1100 divided by 1 plus 0.08 to the first power, which turns out to be $1,114.74. Okay, here's another question that doesn't require any numerical computations. We have two bonds, A and B. A pays $1,000 in 5 years, B pays $1,000 in 6 years. If the two bonds are trading at the same price, which one promises a higher interest rate? Hit pause, think about it for a second, and then hit play for the answer. Okay, this one, again, we can reason through it logically the following way. If the interest rate were the same on these two bonds, then bond A would have a higher price, or present value, since the payment arrives sooner than bond B. But since they have the same price, it must be true then that bond A has a higher interest rate, since the only way present value falls when payments are fixed is if the interest rate rises. We can also show this algebraically the following way. Saying that the prices are equal to each other is the same thing as saying that the present value of asset A is equal to the present value of asset B. So we have 1,000 divided by 1 plus the interest rate of asset A raised to the power 5 is equal to 1,000 over 1 plus the interest rate of asset B raised to the power 6 for 6 years. Next, we'll divide both sides by 1,000 and take the reciprocal of both sides. And we'll end up with 1 plus the interest rate on asset A to the 5th power equals 1 plus the interest rate on asset B to the 6th power. There are a couple of different directions you could take at this point, but I recommend taking the natural log of both sides. And applying the rules of the natural log, we end up with 5 times natural log of 1 plus the interest rate on asset A equals 6 times the natural log of 1 plus the interest rate of asset B. Next, we divide both sides by 5 and make the following argument. Since 6 over 5 is greater than 1, we can argue that log of 1 plus the interest rate on asset A must be bigger than log of 1 plus the interest rate on asset B. And since the natural log is an increasing function, we can also say that 1 plus the interest rate on asset A must be bigger than 1 plus the interest rate on asset B, and of course that allows us to say that the interest rate on A is bigger than the interest rate on B. That's just one way to show the solution to this problem. There are other ways to do it algebraically as well. Okay, last question. I'll give you a hint on this one. You need the quadratic equation to solve this one analytically. Alternatively, you could solve it with a sort of guess and check approach using Excel or something like that. So pause it, give it a shot, and hit play when you're ready to see the solution. The important part of this problem is setting it up correctly. We know that the present value is the price, and that's $1,050, and that'll be equal to the present value of $100 in 1 year plus the present value of $1,100 in 2 years. And we write this all in terms of the interest rate which we're trying to solve for. This may look a little intimidating if you want to solve for I until you make the following substitution. Let's let x equal 1 divided by 1 plus I and do a little rearranging. And so you end up with a quadratic in x, and you can apply the quadratic equation to solve for the 2 roots that would satisfy this equation. One of those roots will give you a positive value for the interest rate, and that's the solution to this problem. Again, you can also take a numerical approach using Excel and just try different values of I that satisfy the equation that we've written down here. And if you do that, you'll find that the interest rate is approximately 7.2%.